Teacher.
Okay, what we were discussing last day is about VLAN, virtual LANs. Virtual LANs is like it's also a local area network, similar to LAN, normal local area network. It is virtual LAN. Why it is called virtual LAN? The reason is basically in the virtual LAN you have similar LAN switch, but the thing is in this LAN switch we can subnet or subnetwork and group different LAN portions. Actually, for an example, let's say there is a 3-story building, right? So there is a 3-story building, and in this 3-story buildings, so there are, let's say 20 computers in each floor. 20 computers in each floor in each building. Let me show this in using an image. Okay. Right. Here you can see all these 20 computers, 20 into 20 into like 20 plus 20 plus 20, there will be 60 computers in this LAN originally. Okay, each floor you have 20 computers. Each floor you have 20 computers. But you are not going to link this, you are not going to network this floor wise. Actually speaking, you can link the first floor, you can connect the first floor to a switch, second floor to another switch, and third floor to another switch. Then you can connect 3 switches together using another switch. So that is the structure that comes to our head, right? That is the normal structure which comes to our head. But here, actually speaking, that is the physical appearance that we can see now. That is the physical thing that we can see. Physically, there are 3 floors and 3, we can simply make 3 networks. But think a situation like this. HR department, some employees are working in the top floor and some are working in the ground floor. So where you need to put all the HR machines to one virtual LAN. And similar in the finance department, let's say the second floor, some people are there, and the first floor or the ground floor, some people are there. So you need to link them together. You need to network them together. Likewise, even physically, regardless of the physical appearance, if you want to link or if you want to create local area networks virtually, it can be done through a manageable switch. But this switch is not, this should not be a hub, because if it is hub is just repeating, just copying and pasting, or just it's not copying and pasting, but just repeating the signal which comes to it in binary format. But the thing is, manageable switch can do more than that. It can understand the destination. It can understand who will communicate with whom. So we are using that feature. We are using that feature to communicate. Actually speaking, it is a kind of subnet. So you can see here 10.10.20.0, which is having 24-bit subnet mask. And here 10.10.30.0 having 24-bit subnet mask. 24-bit means like first 8-bit, the next 8-bit, the next 8-bit. Right? Those are belongs to network. So if something is going to change in that network, so that means it's in a different network. So here within 24 bits, so this 30 comes within 24 bits. No, here 20 comes within that 24 bits. First 24 bits means the first 3 octets. So in the first 3 octets, you can see these two are similar, 10.10. These 3 are similar, 10.10, 10.10, 10.10. But here this is 20, here this is 30, here this is 40. Means it is actually 3 different networks. What do you need to do? Regardless of the connection and the flows, whatever, you need to connect them to a switch. It's okay. But what you are finally here, you have a small switch here, another switch here, another switch here. You are just connecting them to the main switch. But when you are putting the IP addresses, you have to think of putting IPs according to 3 different networks. So automatically what will happen, because of the subnet mask and because of the network IP, automatically there will be 3 networks, 3 subnetworks, which is communicating through the switch and externally through router. Actually, this manageable switch is a single unit, but this switch, even though this switch is single unit, not everyone can directly communicate because they are in different VLANs, different virtual LANs. So they have to like pass, maybe the traffic should be passed through a router because they are in different networks. So that is what the virtual LAN, VLAN is. And here you can see another thing. So here this is engineering department. This is a marketing department. This is accounting department. You can see the example, as I said, the floor 1, floor 2, floor 3. That is connected to one switch. But even though these are in 3 switches, here the accounting computer is basically, you have to put an IP of this, an IP of this, an IP of this, should align them into a single network. How they communicate? They communicate through this switch and through the Cisco router or the routing switch, and through that they can communicate between the interdivisions, the department. It should be routed. The traffic should be routed because they are in different LANs. Actually, even though it's connected to the same switch, here you can see 3 computers connected to the same switch, but still they cannot directly communicate because they are in 3 different LANs. Understand the concept. Is there any doubts about VLANs before we go into the next topic? The next concept is a network address translation, NAT. Here you can see one switch, but this is isolated, this is isolated, this is isolated, but each of these can communicate through a router, even if it's a single switch. So the traffic is manageable because it's a manageable switch. And here you can see the 3-flow example. As I said, these 3 belongs to one, and these 2 and this one belongs to another, and these blue computers belongs to another, right? That's the nature. Okay, the NAT is network address translation. The NAT is network address translation. This is common, especially when you are having virtual PCs in your environment. This is very, very common, right? The virtual PCs. So we usually use NAT, right? Network address translation. That means inside your local network or inside your local computer, you are using a different range of addresses, and external to that, you are using a different range of address. Actually, proxy does something similar to this. What it does, so let's say internally IP is 67.123.65.69 something, but so when you call the router, there is a different address, maybe 192.168.1 something like that. So just an example, right? But actually this device which is used in the gateway need to communicate with the local traffic and also communicating with the global traffic. Actually, globally, okay, so one thing that I can show you, if you go and browse what is your IP, what is my IP, it should tell you just wait. Okay, can you see? It shows 175.157.41 and 242. This is how the internet identifies me. But actually speaking, this is not my IP address. This is assigned by my ISP. There is a network address translation. Why? Because if I check what is my local IP using my terminal, I can check for the local IP of my computer, that is using ifconfig command, but Windows ipconfig, remember in the examination, they will ask the Windows version of this, that is ipconfig. In Linux and Mac OS, it is ifconfig. And press enter, you can see my local IP is, this one, 192.168.8.193. This is actually how my local networks knows me. It is like that. In your home, maybe you are given a nickname in your home environment. You are given a nickname. That nickname is it's a private nickname. Only you and your family members know that. Only you and your family members know that is your nickname inside your family. But when you go to the outside world, you have another name. So actually, NAT is the translation happen between these two. Actually, whatever the traffic comes, okay, let's say I'm using the same router. If my mobile phone is connected to this, and if my mobile phone is connected to this, still my mobile phone will get this public IP address most of the time. So you can just do this when you are having two devices. Right? When you got two devices, you can use this and test. If you want, I can show you using my mobile. Let's see whether can be connected and shared. Okay. Okay, I have muted some reason. Can you see my IP address? 157 at 175 157, right? 41 to 42. Can you see it?
Yes, sir.
Okay. So can you remember the IP address of my mobile phone when I check what is my public IP? Can you remember it? I just show you the screen, and again I'm again sharing. See this? Okay, what is the IP address of my mobile phone? Just see this. It is here. Can you see? Is it same or different?
Yes, sir.
Different? IP version 4.
Different, sir.
One,
Yes,
one,
sir.
huh? 175, 157, 41, 242. What was my, so in computer?
So 175, 157, 40. Same, sir.
Then? That's why I was asking. 41 to 42. Both users same. But you know, these are two devices. Actually, can two devices share the same IP? Normally, not. Normally, it's not.
No, sir.
Normal, because IP is a unique one. But if I check my local IP of my mobile phone, So you can see the local IP of this is 192.168.8.193. Actually, in my mobile phone, it is 192.168.8.194, a different IP. That is the story. Locally, you are given private IPs, right? Locally, you are given private IPs, but in your gateway device, it assigns, so to show to actually it shows to the public different IP address, right? Then when traffic comes, so what should this gateway device? The gateway device should do something, right? Otherwise, how it identifies the traffic? Okay, let's say my mobile phone, I'm going to Facebook, and my computer, I'm going to YouTube. But if the reply is same, what will happen? Yes, Varun? If the reply is same, what will happen? That means I'm going to YouTube using my mobile phone, and I'm going to Facebook using my computer. So should I get same website or different websites? That's my
Different websites,
question.
sir.
So I'm going to Facebook using my mobile, going to YouTube using my laptop. I should get different website, right?
Yes, sir.
But the thing is, actually, I'm requesting from one IP. I'm requesting from this 175, actually, global, that internet sees a request come from this. The response will be sent to this IP. Understood my logic?
Yes,
I'm
sir.
requesting Facebook from this IP. They are sending Facebook to this IP. I'm requesting, same time, I'm requesting YouTube from this IP. They are sending YouTube to this IP. Now, what is the duty of gateway? It should identify actually which private device. Actually, this is like this. Your father is ordering biryani from KFC. And you are ordering, or let's say you are ordering pizza from Pizza Hut. Both will come to same address, right?
Yes, sir.
Both will come to the same address. But now there should be an identifier to give. Your father should not get the pizza and you should not get the biryani. Right? Individually, you should get your own version of it. Actually, that is what NAT does. Network address translation is actually, it's coming to the same address, but locally it's pointing to some different address. NAT device perform this translation and direct your traffic to the correct device. That's it. Understood?
Yes.
It's very simple. So that is the NAT, network address translation. There is a big node, right? There is a big node, but we have discussed in the theory class. This is a revision. I'm just doing in a fast mode. So I'm not going to read out and I'm not going to tell you everything what is there, but you just get the idea. What is NAT? NAT stand for network address translation. And why? Because it is used as routers in the purpose of translate set of IP address to another set of IP addresses. Simply, the theory is that. But practical situation, you saw why it is needed. You need to translate different set of IP address to some different set of IP addresses. Map it. That is NAT. Okay. So with that, I think we are about to finish that technical part. And now we have come to a set of theories again, but this is also a technical part. Modulation, demodulation. Meanwhile, have you installed PayPal or still on downloading?
So download it, sir.
Downloaded. Okay. I'll come to that later after finishing the session, right?
Okay, sir.
Okay. Then modularization, demodulation. This is the task of model. We learn. So because the computer, it uses digital signals. Digital means like two-state logic, or it can be multi-state logic. These signals are having given status, given levels. That is what the digital. It cannot have any level, but it's having given level of signals. But analog signal within a given range, it can have any value. Analog signal within a given level, it can get any value. For an example, think about the temperature. So there is a highest temperature and a lowest temperature. Okay, in a given climate zone, there's a possible highest, possible lowest. In between that, it is possible to have any value between the given max and the min. That is, we call analog data. It's not analog signal, it's analog data. Actually, when the data is transmitting from one location to another location, when data moving from one place to another place, we call that a signal. Data at rest is basically data of information, but data at transmit, we call it a signal. So analog data is data at rest. Analog signal is data at transmission. When data moving from one place to another place, the mechanism is called a signal. Okay. Then the computer uses digital data, digital signals. But you are transmitting this to a faraway place using analog signals. What is the reason? Because if you try to transport this, if you try to send this to a long distance, if you try to send this data to a long distance, there will be a problem. If you are using a digital signal, the issue is basically there is higher tendency to damage the signal. But for a short distance, yes. For a local area network, you can transmit digital signals. Doesn't matter because it's a short distance. But for a wide area network, it is little hassle. It is not a very good option to transport a digital signal. Therefore, the easiest and fastest and comfortable and technically feasible solution is to transport analog signal. Therefore, we are using existing telephone infrastructure which transports analog signal. So any level of signal can be transmitted between a given range. There's a given max. Any level means, don't think that any, right? Any level means even light can be transmitted, even radio signals, not like that. But there is a given bandwidth, given highest, given lowest. In between that, any signal is accepted. Between a given highest and given lowest, in between that, any is accepted. That will be transported from using the existing telephone network. But computers, so use easy way. The easy way is digitized data. That is easy, simple, right? So for real world, it is difficult to convert from the analog to digital, but the thing is, once digitized, electronic device can easily understand. Think about a bulb, it can understand on-off status very simply. When current is provided, when you are powered, the bulb is powered, it will turn on. When the power is cut down, it will turn on. 1-0 logic. It's very easy. Therefore, devices are digital, but transportation mechanism is analog. Therefore, there is a need for converting digital to analog, analog to digital, and that is what done by this modulator, demodulator. Actually, you can see this. When digitizing signal, you need to think about two things. One is quantization, the other one is sampling. So I have created a graph. Quantization means the different levels. Quantization means the different levels of signals. You are going to divide y-axis to equal size chunks, equal size slots. And these are quantization level. The higher the quantization level, you can get more accurate data, right? Because you can get exact value. But lower the quantization level, you will not get the exact value, you will get a rough value. It is better to have higher quantization level, but it will require more bits. More quantization levels will generate more bits. Okay, here how many quantization levels? You can see 1, 2, 3, 4, 5, 6, 7, 8. In order to have 8 quantization levels, how many bits you need? Hello. To represent eight levels, how many bits you need?
Sir, can you repeat the question, sir?
There are 8 so here, believe me, then there are like think that. So there are 8 quantization levels. In order to represent 8 quantization levels, how many bits you need? Yes. How many bits you need? We discuss in different questions. When we learn binary, we just discuss this in different, when representing colors, representing HTML colors, representing images, representing logic gates, number systems. We have learned this in several places. Here also the same. 8 levels are there. Then how many bits are needed to represent that 8 levels?
So 4 bits.
If there are 4 bits, 2 to the power 4, there will be 16 levels.
3 bits.
3 bits enough, right? 3 bits you can represent 2 to the power 3, 8. So you can say the levels, you have to digitize this. No? Therefore, the levels you have to, like the first level, you can say it's 0, 0, 0 level. The second level, 0, 0, 1 level. So likewise, up to 1, 1, 1 level. So you can just write 0, 0, 1 level, 0, 1, 0 level. Likewise, there will be 3 bits and there are 8 levels. That is example only. Right here, I have given some more details in the below. Time axis is divided to equal interval. That is called sampling. So higher the sampling, what will happen? Higher the sampling rate. What's the result of higher sampling rate? Okay, let's see that. Let's think like this. So there are 8 levels. No, 8 level means 3 bits. Okay, let's say this is divided to 3 samples. Only 3 samples, right? The first sample is here. Let's say first sample is here. The 0th sample is here. Starting sample. The second sample is here. And the third sample is here. Then what is the signal? What is the corresponding digital signal? Here you can see it is 0, 1, 2, 3, 4, 5, 6. 6 is 1, 1, 1, 0. Here 0, 1, 2, 3, 4, 5. 5 is 1, 0, 1. Here 0, 1, 2, 3, 4, 5, 6. 6 is 1, 1, 0. Here 0, 1, 2, 3, 4, 5 and half, but 5 is 1, 0, 1. Okay, this is the signal. If there are 4 samples, so how many samples? 1. So sorry, if there are like here 1, 2, 3. Ending signal is also, you can get ending signal is basically 0, 0, 1. That is the last here. 0, 0. Okay, you can see this is your signal. This is your digital signal. That digital signal has level 6. After that, it's falling down to level 5. 6 again. 5 again. And 1. This is your digital signal. 6, 5, 6, 5, 1. So this is your digital signal. But is it really accurate or is it really good one? Yes, it has less number of bits. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 bits. 15 bits means easy to transmit. Only small amount of bits. But is it very good way to convert the signal to digital format? Or is it accurate? What do you think? Varun?
So no.
Good. Is it accurate?
So no, sir.
Yes or no?
No, sir.
So what can we do? What can we do to make this more accurate? Yes, how can we make this more accurate? Actually, if you try to use the middle points and generate the analog signal, analog is something like this. The correspondent analog signal will be starting from here, going to 5, going to 6, going to 5, and so this is the analog signal. If you are generating, this will be the analog signal after conversion. I think you know this. You said that you are going to a theory class.
Yes, sir.
So didn't you learn these things?
So we have skipped this lesson, sir.
Why?
And we have gone to flowchart.
The reason?
So sir said that we don't have clear notes for this unit, sir.
Mm,
So he's gathering the notes and he said that he will prepare the notes and give it.
okay. Right. Anyway, this is the signal that you are going to regenerate. This is the analog, but you can see it's not the same, but it's something similar. It's not the same. But if you double the sampling rate means, so if you are going to take another sample in the middle, you are going to take sample in the middle. Now you are doubling the sampling rate. And now you are trying to digitize this. Here, let's see, this level is 7. So I'm typing this now. What is this? 0, 1, 2, 3, 4, 5, 6, 7. Yeah, 7 is 1, 1, 1. Earlier we took 6, it's wrong, but anyway, let's say 7. And here 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6. 5 is 1, 0, 1. 6 is 1, 1, 0. And then 0, 1, 2, 3, 4 point some. Let's use 4, 1, 0, 0. And this is 0, 1, 2, 3, 4, 5, 6. 1, 1, 0. And then this is 0, 1, 2, 3, 4, 5, 6, 7. It's 1, 1, 1. And the next 0, 1, 2, 3, 4, 5. Let's say 5. 0, 1, 2, 3, and 3. The last one is 1. Okay, doubling the sampling rate. What has happened to the number of bits?
Increased.
Increased. So earlier it was 1, 2, 3, 4, 5, 5 into 3. Now it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So closer to 2 times. 2 times of the previous one. It has increased. So if you increase the sampling rate, if you double the transfer rate, if you double the sampling rate, what will happen? It will double the number of bits in the digital signal. As a result, now let's draw the digital signal. 7, 5, 7, 5. The next is 6. Next is 4. Next is 6. Next is 7. Next is 7. After that, next is 5. And next is 3. And next is 1. Let's try to regenerate the signal. If you try to regenerate the signal by linking the middle points, Oh, sorry. I'm drawing in another color to make it easy to understand. Just link the middle point, this point, this point, this point, this point, this point. Yes. Ugly drawing. Actually, I have to curve this, but I'm not curving. I'm just trying to link the middle. But actually speaking, you are curving this, right? Okay, this is the signal. So you will see some signal like this. Okay, now can you see the signal is more accurate than the previous one. The signal is more accurate, but still not the same. Still not the same. Maybe you can increase sampling another 2 times. And like you have to again sample, so you have to again divide into some more samples. So can you understand why sampling is important?
Yes, sir.
So what happened when you increase the sampling? The
So the
quality
number of bits
will be high, and the quality of the signal, quality of the digital signal
will be high.
Will be
increased.
Yeah, will be increased. When you increase the sampling, the quality of the signal will be increased, and also when you increase the sampling, the signal quality increase, number of bits increased. Right? Have you seen this? This is there when you are downloading MP3 songs also. They mention the sampling rate. Sometimes, but you have never considered that. MP3 is a digital format of music. Sample rate. Here you have different CD quality images, CD quality audio. So increase the sampling rate here. You can see if it is 16 to 96 kbps, the quality size is small, the quality is also small. How many samples per second? Huh? How many samples per second? 8,000 samples per second, right? Don't think that it is a small amount. 8,000 samples. That means 1 second is divided to 8,000 units. Understood?
Yes, sir.
If you cannot understand, tell me, right? This is technical, but it's very important. Right here, can you see? The sampling rate is this. The higher the sampling rate, higher the quality. Okay, the MP3 normally sampling rate 8,000 is low quality MP3, but still 8,000 samples per second. Next quality, 16,000 samples, double of that, 16,000. The next quality may be like 4,000 samples per second, 48,000 trans. Now even you have like a higher, very higher number of sampling, 128,000 samples per second here. These are basically some of the sampling rates. Right? When you increase the sampling, it will increase the quality. Okay, when you create MP3, here can you see? It will ask what is the sampling rate that you need. 96,000 samples per second will be one of the best. Right? But 44,000 is CD quality, we call CD quality, but 96,000 is more quality than that. Higher the quality, higher the number of bits, and higher the quality. Okay, quantization. What about the quantization? Yes, that is bit depth. Quantization is bit depth. How deep? So what are the levels that you're going to get? If you are getting only few levels, and if you're getting only few levels, that is also a problem. But you can simply increase the number of levels. The number of levels is how you are going to divide this. Right? How you are going to divide this axis. Okay, let's see here 8. No, what happened if it is 16? If there are 16 bits, how many? If there are 16 levels, How many bits you need?
4 bits.
4 bits. Then if there are 32 levels, how many bits you need?
5 bits.
5 bits. Okay, that will also increase the smoothness of the signal, right?
Okay.
But the thing is, like, increasing doubling that will not cost you more because it's just adding one more bit. But here, if you're doubling the sampling, it will double the bits. But if you double the quantization, it will not double the bits. Why? Because earlier maybe you write like 110, 101, 100 is the signal. But if you double that, the next time it will be like 1101. Next time 0110, then 0101, so 0100. So something like this. Right? Double the sampling, double the quantization will not double the bits. Because it's going to add only one bit. 1, 2, 3 bits will be added. Here, how many bits? You can see 4, 8, and 12. Here, 9. 9 is increased to 12 because of doubling. That is not a big cost. Right? But the thing is, if you double the sampling rate, aggressively increasing the number of bits. Okay, both are needed. Higher the quantization, higher the sampling, you will get a better signal. Right? High quality and more accuracy. Quality is this direction. Accuracy is this direction. So you need more accurate, and both direction will together preserve the quality and accuracy. Understood this theoretical part, digitization of analog signal, sampling and quantization. Okay. So now digitizing the signal, and you saw how to get the analog by just pointing the middle points. You can generate the analog signal back. But both analog digital formats are okay. But how to transport? Still, we have not learned the transportation mechanism. Transporting this signal is the next important thing. Transporting this signal is the most important thing. Okay. So your theory class, is it individual or like a group class?
Group class.
Right. Okay, even I have seen that, I'm not sure so who's the teacher, and I'm not going to criticize or comment on that. But the thing is, basically, you know that in A-level ICT subject, there are a lot of teachers in Sri Lanka. So even are doing whole classes. I personally know some people, but I'm not going to name them because like it's tarnishing their goodwill. I just don't want to do that. But you should know the situation. So where the A-level ICT teachers are there. We were teaching for degrees and then actually for hobby, and also just because of the student request, we are doing A-level ICT, not to like do the mass classes and earn massively. But there are teachers doing mass classes and massively doing A-level ICT. But some of these teachers, if they ever given the papers, they also don't know how to answer the papers. That's the thing, because sometimes they know the theory, sometimes they know the answers to the past papers by heart, because they know the pattern. Pattern is this, and these kind of questions will come. If these kind of questions are there, these are the answers. But that is not really the A-level ICT in Sri Lanka. A-level ICT is a truly dying section. Really pathetic about that, because a lot of whole class teachers, maths class teachers, they don't have the proper idea. Actually, they might have knowledge, but the thing is, it's very limited. They are not really having the idea about the ICT field, the practical implementation, how these things are working. Technically, what is the depth of the subject? They don't know. This is the engineering subject. But most of them are not having that engineering portfolio to teach the subject. That is the situation. That's why I just ask. So you can see you have experience now. But the problem is when these juniors and the new students find in their teachers, they will only think about their appearance and how many students are there in the class. They don't actually analyze the teacher and the teacher's background. So that is the situation. So you asked from me any section, I can technically explain this up to the engineering discipline. I'm comfortable on that because I have done the particular subject as well as I have gone to the depth of that, practically implemented exposure and practical applicability, how it's working and how we can use that in the industrial development and industrial applications, not just in software, because some software engineers are doing classes, I know. They have good depth knowledge in software, but again, the problem is when it comes to the networking and hardware, they are nil. And some, rarely some network and hardware people doing the subjects. I have seen less than handful, because most of them are having theoretical knowledge in networking. They're not practical. That's a problem. And some are good in software, of course, but the thing is, then they are not good in networking. Some are good in networking, they are not good in software. There is a situation. So this market, I don't know if they are going to keep this market. Soon, the A-level ICT, the quality of the student will not be there. Especially when we are teaching to the university students, we are telling that when we are doing visiting to university students, we understood most of the A-level ICT students are coming without a practical knowledge, coming without exact idea of the subject. You should learn with the proper technical details. The reason is because in the university, then it's very, very easy to apply this. Some of these subjects are there in the university again. But you don't want to look at an alien, look at as an alien at that time, because if you know the subject, in the university also, it is the same subject. But I have seen A-level ICT students are looking at these subjects in the university levels as aliens. That should not happen. Therefore, get the technical idea of the subject, right? That is really required. Okay. Then right now we know how to convert the signal, how to digitize that, and how to make it back to analog, and the importance of the sampling rate as well as the importance of the quantization levels. Okay, the problem is how can we send this to a faraway place? Then you have the modulation and demodulation in place. Actually, this is called shift keying also. Shift keying is coming basically when there is a digital signal modulated with analog signal, we call shift keying. But when there is an analog signal and we are mixing it with analog signal, it is called modulation. Same principles, the same mechanism. That is the simplest way of understanding that. Okay, what they do? They will take a signal and used a high frequency HF, a high frequency signal, and then sending it to a faraway place. Why? These radio signals are powerful. You can transmit that to a distance without damaging. Therefore, we are using a high frequency radio signal basically to modulate. Here, this is a low frequency. My voice is very poor. So if I talk, can a city hear my voice? I don't think. If I talk, even my homemates cannot hear my voice. That kind of weak voice that I have. I cannot shout, right? Beyond my home area, beyond my, maybe can I shout to the entire village? No, it's not possible. My voice is not propagating that far. It's not going that far, right? But if there's a radio signal, even though I cannot hear the radio signal, if I can mix that with a radio signal and send, then I can start a radio station, and my villagers will be able to hear my voice through the radio transmission. And the next thing is, if I try to use a bandwidth or high frequency, then if I can use very good transmitter, then even I can transmit my voice to another continent or another country. That is possible. But the thing is, there are legal restrictions when building such transmitters and no. But if you get acceptance and if you are having permissions, you can build a radio to transmit your voice to another country. That is possible because using high frequency signals. And the modulation here, you can see AM, amplitude modulation. So in these areas, you are reducing the amplitude. In these areas, you are increasing the amplitude. Amplitude means the power of the signal. So the power of signal will get high, low, high, low, and propagate. So what is the disadvantage of this system? There's a fundamental disadvantage of AM, amplitude modulation. What is that? It's very easy, right? It's very, very easy. You can see when the signal strength is high, you are transmitting high powerful signal with the same frequency. You are not going to change the frequency, right? High powerful signal. My drawings are ugly, but it's not going to change the frequency, high powerful. But when signal is like lower, it will transmit same frequency, but low powerful signal. And again high. So what's the problem? Do you think is it a good way? AM? Have you heard AM radio? AM radio have you heard AM radio before?
No, sir.
Earlier days there was a radio, right? You can change whether you need AM channel or FM channel. You can change to AM channel or FM channel in that radio. When you change to AM channel, you can listen to the radio, but you can ask something like, it's like ocean waves. It's likewise, you can have, like when signal power is high, voice have you heard such signal? No, never.
No, sir.
Right? It's like with the noise, and so very high amount of noise, because when the signal strength is low, the signal length when the signal strength is low here, but still the other signals are there in this environment. Still the other signals are there. So let's say noise signal, there's a noise signal, and any channel noise is there. So that is in like we are learning that in physics, Shannon's theorem, and so different theorems are there for calculation noise. But any channel, in my channel also, you can hear sometimes birds are singing, dogs are barking, maybe cats saying meow, meow, something. People are talking in the background. That is there. Noises are there. In any environment, this environment is also, you can hear some noises. That is practically there. But the problem is you cannot avoid. You cannot like keep 0 noise. There is a noise. Maybe let's say this is noise. I mean, noise it's a change in noise. So let's say this is your change in noise in the channel. And this is your signal. And your signal is like really powerful in some times. So in these situations, you cannot hear the noise. But when the signal moves down, what will happen? The noise is powerful than the signal. Now you can hear the noise. But when the signal is powerful, you will not be able to hear the noise. But when it is not powerful, the noise is dominating. Can you understand why this AM is not very good?
Yes, sir.
When noise is there, the noise can dominate. But sometimes noise is cut down because the signal is high. But sometimes noise presents. That is why you can hear, that is why you can hear the tidal sounds. So wave sound. It's like wavy. That is the problem of AM. Therefore, it's not really popular. It's faster, easy to do the modulation. In the demodulation, you are extracting the signal back, the high, low, you're extracting that back. That is the demodulation part. Okay, there are some few more to learn. That is about the FM and PM. PM is also used heavily, and you can see this is AM. But in FM, frequency is changed. Right? FM frequency is changed. And in PM, pace is changed. Pace means the direction. So PM is one of the best because you are not going to change the frequency and you are not going to change the amplitude. you are changing the direction. That is okay, because the frequency is preserved. Frequency is one of the most important factor in the signal. If you can preserve it, and if you can preserve the amplitude. So anyway, FM is popular, and PM is also a very good way of modulating. PM is just changing the angle of the signal, pace of the signal, the relative angle. So let's discuss about these things more in next week, and I think next day. Yeah, this then you have the topologies like EC2. Yes, these are EC topologies, and yes, then 7-layer architecture. I think yes, we have discussed, but we have to just summarize that, and the encryption part. That will conclude the particular lesson. So maybe within next 2 days we can finish it easily. Okay.